day, everyone. This is Carla Tuting, a second-year college student from Negros Oriental State University, taking up a Bachelor of Secondary Education major in mathematics. So now, let's solve trigonometric equations. Trigonometric equations is any equations that contains trigonometric functions. It is one or more that involves of the six trigonometric functions such as sine, cosine, tangent, cotangent, secant, and cosecant. But always remember that in solving trigonometric equations requires the same technique as solving algebraic expressions. So now let's start. So given these equations, we have 4 sine x plus 1 is equals to 2 sine x plus 2. Now, we need to be able to look at the situation and then solve for the x. But first thing we do is that we need to combine like terms. And then, let's now subtract the 2 sine x as well as 1. So let's do it. So, 4 sine x minus 2 sine x, we have 2 sine x is equals to negative 1 plus negative 2, we have positive 1. So for now, after this, we need to divide both sides by 2. So let's cancel the 2. So we only have sine x is equals to 1/2. Now, to solve for the x, we can definitely take the inverse of sine 1/2 or look at the unit circle. This is our unit circle. Quadrant 1, 2, 3, and 4. And observe that 1/6 pi has a value of 1/2 that located from the quadrant 1, as well as 5/6 pi located at quadrant 2. Therefore, the way we express this solution will be x is equals to 1/6 pi and 5/6 pi. So this is it. This is the value of our x. X is equals to 1/6 pi and 5/6 pi. There are also steps in solving trigonometric equations. Now let's solve for these equations. We have 2 cos x minus 1 is equals to 0. The step 1, isolate cos x. So let's do it. Cos x is equals to 1/2. From there up to here. So, the step 2, determine in which quadrant cosine is positive. Use the inverse function to assist by finding the angle for the quadrant first. So, we use that angle as the reference angle for the other quadrant. So, note that cosine is positive in quadrant 1 and quadrant 4. Then, the reference angle in quadrant 1 must be 1/3 pi and in quadrant 4 must be 5/3 pi. So, the answer is cos x is equals to 1/3 pi and that located from quadrant 1 And from quadrant 4, it must be 5, 3 pi. So this is it. So let's try for the other equations. So we have cos x is equals to negative square root of 2 over 2. So in these situations, we all find the answers that satisfies in these equations. So cosine is negative in quadrant 2 and quadrant 3. So we just simply look. So as you can see here, negative square root of 2 over 2 is located from the quadrant 2. So it's given by 3, 4 pi. And in quadrant 3, negative square root of 2 over 2 is 5, 4 pi. So the answer must be, so we have cos is equals to 3, 4 pi. 3, 4 pi. And in quadrant 3, we have 5, 4 pi. So always remember that in this equation, just simply look from the unit circle. Thank you. So for now, let's solve for the theta. Given this equation, which is tan the quantity of theta plus 1 is equals to negative square root of 3 plus 1. So now, the step 1. We use algebraic operations to manipulate the functions by subtracting 1 from each side. So let's do it. Tan theta plus 1 minus 1 is equals to negative square root of 3 plus 1. So we have tan the quantity of theta is equals to 1 minus 1 is 0, right? Then negative square root of 3 plus 1 is equals to negative square root of 3. So we have it now. Then step 2, to isolate theta, we perform the inverse trigonometric operation. So let's do it again. So we have, so this is the step 2, right? This is the step 1. The step 2 is tan raised to the power of negative 1 times the quantity of tan and theta is equals to tan raised to the power of negative 1 and the quantity of negative square root of 3. So we came up with theta is equals to negative square root of 3. Okay, step 3. We use the unit circle to solve for the theta. Recall that tan theta is equals to sine theta over cosine theta. Okay, therefore, to have equaling 1, both sine and cosine must be equal to one another. So therefore, we have this one. So tan the quantity of 2, 3 pi is equals to the square root of 3 over 2 divided by negative 1/2 is equals to the square root of 3 over 2. times negative 2, 1. It is a reverse proportion here. Negative 2 over 1. So, the square root of 3 over 2 times negative 2 over 1 is equals to negative square root of 3. Another, tan the quantity of 5, 3 pi is equals to, as you can see here, 5, 3 pi. Negative 3 over 2 over 1 half is equals to negative square root of 3 over 2 times 2 over 1. So, negative square root of 3 over 2 times 2 over 1 is equals to negative square root of 3. So, the answer for this equation to our theta must be 2 pi 3 and 2 pi 3 is located in 2 pi 3 quadrant 2 and 5 3 pi that located in quadrant 4. So, the answer for our theta is this. So, we have theta is equals to 2, 3 pi, and